question that I'm next going to do is an example of analysis with a structured data set. The data set that I'm going to use will be from your notes, section 2.5. We start off with a data set that consists out of the following. We have 3 sires, so S equals 3. We have under each sire 2 dams, so D equals 2 dams per sire. So in our data we already know from the structure that it's 1, 2, 3, 4, 5, 6. So we can already see the pattern emerging, and we have 6 half-SIP families. Now let's add the data. So the data that we have is 3, 4, 4, 2, 3, 4, 4, 3, 4, 5, 4, 4, and 5, 6, 5, 5, 4, 4. For clarity's sake, let's do the following. So half-SIP family 1, half-SIP family 2, and half-SIP family 3. Now in terms of K is our offspring per dam. And we can clearly see that that is 3. 1, 2, 3 individuals per dam per sire. Next, what we can do is do some basic calculations regarding totals. So the first one is the dam family totals. That's 3 plus 4 plus 4, which is 11. The next one is 9, 11, 13, 16, and 13. So this, what we've just calculated, we refer to as the dam family total. The next one is to calculate the sire family total. So remember, this is a dam. This is dam family. The next one is the sire family total. So it will be the complete one. So it's just 11 plus 9, which gives us 20. 11 plus 13, which gives us 24. And 16 plus 13, which gives us 29. The only remaining calculation that we therefore have to do is that of the grand total. The grand total in this specific case comes out to 20 plus 24 plus 29, and that gives us 73, and that is our GT, or our grand total. Now we have our data set, and we have the structure regarding the data set. So let's go and have a look at the calculations that we now need to do. So what we are doing is we are working towards a ANOVA. And in order to do that, we have to make some basic calculations. So the calculations that we are going to do is for terms so that we can populate our ANOVA. The first one is A, and A is just the sum of the square of all the x's. So that means that in our data set it is 3 to the power 2 plus 4 to the power 2 plus 4 to the power 2 plus the next column plus the next and it ends with 5 to the power 2 plus 4 to the power 2 plus 4 to the power 2, and that gives us a grand total of 311. So just to remind you guys, where does the 3 comes from? So it's 3 to the power 2 plus 4 to the power 2 plus 4 to the power 2 plus 2 to the power 2 plus 3 to the power 2 plus 4 to the power 2, and so it goes to 5 to the power 2 plus 4 to the power 2 plus 4 to the power 2, and that gives us then the 311. The next one that we need to calculate in order to populate our ANOVA is B. B is basically the sum totals in terms of the DAM family totals. So that is just the sum of all the x's to the power 2 divided by k, which, remember, is the offspring per DAM. So in this case that boils down to 11 to the power 2 divided by 3 plus 9 to the power 2 divided by 3 plus 11 to the power 2 divided by 3 plus 13 to the power 2 divided by 3 plus 16 to the power 2 divided by 3 plus 13 to the power 2 divided by 3. That gives us 121 over 3 plus 81 divided by 3 plus, and you can see the general trend, the last one being 169 divided by 3. That leads to 305,67. The next one that we need to calculate is C. So let's make some space. So just to recap, that's A, that is B, and C basically is the sum of the sums of the x's to the power 2 divided by kd. Remember, k is the offspring per DAM, which was 3, and d was the number of DAMs per sire, so it's 3 times 2, so that value becomes 6. The sum of x, that we've already calculated previously. Just to remind you guys, so we've worked with the 11, the 9 previously, now it's the 20, that's the sum of the sum, because it's the sum of the sum, 24, 29, and we divide each of those by 6. So straightforward, it's basically 20 to the power 2 divided by 6, and remember you have 3 sire groupings, so it will be 3 terms. It's 20 to the power 6 to the power 2 divided by 6 plus 24 to the power 2 divided by 6 plus 29 to the power 2 divided by 6, and that gives us 66.67 plus 96 plus 140.17, which adds up to 302.83. So C, just to remind you, is then 302.83. The last one that we need to calculate is D. And D is extremely straightforward because D is just the sum of the sum of x to the power 2 divided by k ds. So in our case, that would be the grand total, which is 73. So it is 73 divided by k was the offspring per dam, that was 3. D was the dams per sire, that was 2, times S, which is the number of sires, that was 3. So it is 73 to the power 2 divided by 18, and that gives us 296.06. So that is D. So to recap, we have A 311, we have B 305.67, we have C, which is 302.83, and we have D, which is 296.06. Okay, so we've previously ended with A, B, C, and D. What we are now going to do is we are going to proceed with the ANOVA. First of all, remember how ANOVA usually looks. You have the source, we have our degrees of freedom, our sum of squares, and our mean squares. So the first factor that we're going to have a look at is between sires. So we had 3 sires in our group, so it's S minus 1, and that is 3 minus 1 equals 2. Our sum of squares is 302.83 minus 296.06. That leads to 6.77. Now remember the mean square, in other words it's the average, and you take 6.77 divided by 2, and it gives you a mean square of 3.39. Next, we have to look at the between dams. Now remember, you have 3 sires and you have 2 dams per sire. So it's S times D minus 1. That gives you 3 times 2 minus 1, and that leads to 3. Now your sum of squares is 305.67 minus 302.83. That is 2.84, and your mean square is then 2.84 divided by 3. That gives you 0.95. Guys, remember this was C minus D and B minus C. Then between offspring, So offspring was k. So how many offspring did we have? We had k equals 3, so it's SD times k minus 1. That is 3 times 2 times 3 minus 1. So it's 6 times 2. So that gives you 12. Now, in this specific case, sum of squares works out to 5,33. So remember then the next one is the sigma squared w plus, and it is k times, with the k representing the offspring, times sigma squared d, and the first one is sigma squared w plus k times sigma squared d plus kd times sigma squared s, which refers to the sires. That brings us to our last few steps. We need to now calculate the different variance values, and we need to calculate the total phenotypic variance. So first of all, what do we know? We know that sigma squared w plus k sigma squared d plus kd sigma squared s equals 3,39. We also know that sigma squared w plus k times sigma squared d equals 0,95, and we also know that sigma squared w equals 0,44. So 0,44 equals sigma squared w, that is sorted. So let's have a look at how to calculate sigma squared d. That is then simply sigma squared w plus k times sigma squared d equals 0,95 minus 0,44 divided by k. And remember, k was 3. That gives us a value of 0,170. So for instance, we would like to calculate sigma squared s, sigma squared w plus k times sigma squared d plus kd sigma squared s equals 3,39 minus, this in brackets is 0,95 divided by kd. K is 3, dams per side is 2. That gives us a value of 0,407. So sigma squared p equals sigma squared s plus sigma squared d plus sigma squared w. That gives us a total value of 1,017. And there you have it. How to go from a structured set of hierarchical data all the way to your variance. Your variance, your total phenotypic variance, for the sire, for the dams, and for within the offspring.